Good day everyone! Ma'am Rech is here again for the new learnings in mathematics. Today, I will discuss about subset of a line. For our objectives, the learners are expected to illustrate subset of a line, define, identify, and name subset of a line. Let us have a recap about what I discussed last time. Last time, I discussed about undefined terms. The first undefined terms that we have is a point. Point has no length, width, or thickness, occupies no space. It can be named using a big letter. So this figure is point J. When two points are connected, it became a line. When point J is connected to point C, its name is line JC. A line has its parts or subset. There are two subsets of a line. The first is line segment and the second is ray. Let's talk about line segment. Line segment is a part of a line that has two endpoints. In this line JC, if we cut this line from point J to point C, it gives us line segment JC. It is denoted as like this, and it can be read as line segment JC or line segment CJ. The name of a line segment can be interchanged. In this illustration, there are 4 points on the line. Point L, point O, point V, and point E. The segments are segment LO, segment LV, segment LE, segment OV, segment OE, and segment VE. We have 6 segments found in the illustration. We can easily determine the number of segments on the line by using the formula number of line segment is equal to n times the quantity n minus 1 divided by 2, where n is the number of the points on the line. So let us substitute 4 times the quantity 4 minus 1 divided by 2. Let us simplify the operation inside the parentheses. So that is 4 times 4 minus 1 is equal to 3 divided by 2. 4 times 3 is equal to 12 divided by 2 is equal to 6. So we have 6 number lines. It is true that we enumerated 6 segments a while ago. A segment is commonly used to represent the length, height, or width of a certain object and the distance between two objects. The edge of the table represents as a line segment. The length of the line segment can be measured To find the measure of the distance between any 2 points or length of the line segment, first identify the coordinates of the points, then find the absolute value of the difference of the coordinates. In this figure, we have point L, point O, point B, and point E. The coordinates of point L is -4, point O is -2, point B is 1, and point E is 5. So let us find the measure of the line segment OE. The coordinates of point O is -2, and the coordinates of point E is 5. Let us find the absolute value of the difference of the coordinates of point O and point E. So line segment OE is equal to the absolute value of -2 minus 5. So -2 minus 5 is equal to -7. So the absolute value of -7 is 7. Remember, the absolute value is always positive. So the distance between 2 points is always positive. So let us check if the distance from point O to point E is 7. So let us count. 1, 2, 3, 4, 5, 6, 7. We got the same answer. So the distance or the measure of a line segment OE is 7. So let us have another example. Let us find the distance or the measure of segment LE. The coordinates of point L is -4, and the coordinates of point E is 5. So let us find the absolute value of the difference of the coordinates of point L and point E. So we have the absolute value of -4 minus 5. So -4 minus 5 is equal to -9. So the absolute value of -9 is 9. So the measure of segment LE is 9. The second subset of a line is ray. It is a part of a line that begins with an endpoint and extends endlessly in one direction. If we cut this line, we have ray JC. It begins with point J and extends endlessly to the direction of point C. It is denoted as like this. It can be read as ray JC. Another ray that we can get from the illustration is ray CJ. It begins with an endpoint, which is the point C, and extends endlessly to the direction of J. So it is denoted as ray CJ. The name of the ray cannot be interchanged. It always started with an endpoint and extend endlessly in one direction. Ray CJ is different from ray JC. Opposite rays are two collinear rays with same endpoint but extending in opposite direction. In this illustration, we have ray AJ and ray AC. The two rays are considered as opposite rays because the endpoint that they have is the point A and they extend in a different direction. So, they are opposite rays. Ray AJ extend in the direction of point J and has endpoint point A, and ray AC extend to the direction of point C and it has an endpoint which is the point A. The real world example of a ray is a sun ray. So, let us try ourselves. In this figure, line MT intersect line AH. So, the line segments are line segment ME, line segment ET, line segment MT, line segment AE, line segment EH, line segment AH. The rays are ray ME, ray MT, ray ET, ray TE, ray TM, ray EM, ray AE, ray AH, ray EH, ray HE, ray HA, and ray EA. The opposite rays are ray EM and ray ET, and ray EA and ray EH. Thank you guys. I hope you learned from me. So you can now answer your activity in your module. Thank you.